it is first before we start talking about XDCR. So Couchbase, for those of you that don't know, we're one of the leading NoSQL database projects. We're a distributed database that focuses a lot on servicing requests out of RAM to provide a lot of speed. NoSQL gets split into a couple different paradigms, if you will, columnar, key value, document-oriented, graph. We are a key value as well as documented-oriented database, so we'll work very well for either of those use cases. Everything we make is available underneath the Apache 2.0 license, so if you're curious about that, that's what it is. Our software packages, we've got a couple different versions. We've got both enterprise and community editions. The source code for all this is available for you if you're curious what that looks like. It's a mix of Erlang and C, so it's available if you're curious about what's underneath the hood of Couchbase. So, in describing Couchbase Server, there's a couple ways to categorize it in terms of why you would want to use this over a traditional relational technology or maybe one of the other NoSQL technologies. And these 4 points kind of help differentiate us in those areas. So first is easy scale. We are a clustered technology. It's essentially a distributed peer-to-peer network of nodes working together to service your data requests. And with that, what we're able to do is actually grow those clusters without any kind of application change, without any kind of configuration change at the app server side. We're able to do that online, and it's a very simple operation to do. So it's something that people will leverage on a regular basis to expand their capacity, their capabilities, to help with capacity planning, all without having to take a single minute of downtime. The always-on 24/365, this software is really designed to be up, for Web 2.0 projects, things where, you don't have the luxury of taking an hour maintenance window on a monthly, weekly, or whatever basis. We support almost every single operation as an online operation. And when we say online, what we mean is the application is running, it's sending requests to our system servicing them, regardless of if you're doing backups, if you're upgrading the software, if you're adding capacity, if you're updating the hardware, whatever you want, everything is generally done online. Consistent high performance. We leverage Memcached. It's probably one of the top. It's leveraged in the top 7 out of 10 web properties in the world as a caching solution, and we actually use that to service a large bulk of the requests out of Couchbase. And since it's an in-memory hash map, it allows us to service requests, at millisecond or sub-millisecond response times. A lot of it's bound mainly by network I/O, and on environments where we have very good networking to work with, we've seen it in the tens of microseconds in terms of response time. Lastly, flexible data model. We use JSON documents as the model, so in those cases there are no alter tables to run, no issues when you're upgrading your schema in production. It's a very flexible format. If we look at it, JSON is a way to add a data structure, a very simple data structure to a string that maps extremely well to the programming objects that you as developers are running in your application. And so with that, it negates the need for any kind of ORM model that you might be traditionally used to with relational systems. And it allows for a faster, more seamless development model compared to working against tables. So the 2.0 product that we're talking about today is new as of December 2012. We had a number of features that we're really excited about, and one that we'll be talking about specifically as the focus of today's webinar. The first is JSON support, right? The second is incremental MapReduce, and essentially that's the ability for us to divide and conquer, spread out the work, and distribute it over all the nodes that make up Couchbase so that we can do something interesting with that JSON. We've got the ability to index and query against those documents, which is different from how our previous model of Couchbase worked. And lastly, the focus of today's webinar, cross-Datacenter Replication. just so you get a sense of who we are, what kind of people are using our technology. Here's a slide that goes over, a short list of, some of the customers that are using us in production today. So large companies like AOL, Orbitz, Zynga, Docomo, all number of different places using it for different use cases, using it with different technologies, all with the same goal in mind, right? A reliable data store that services a request fast, that scales with their needs, and allows them the flexibility to keep things running and keep their customers happy and have a good experience. So, cross-data center replication. Let's start talking about that. We use the XDCR term quite frequently, but it's probably more technically accurate to say that what this is the ability to replicate data between Couchbase clusters. So it's a replication between Couchbase clusters where those clusters can be located wherever you like. They could be within a single data center, they could be at your home office, they could be located across the continent, even in Europe and Asia Pac, right? So it allows for a lot of different configurations, and it gives you a lot more interesting things that you can do with Couchbase. So some of these things specifically, being able to have an offline cluster that's not used for customer traffic, that can be used for other internal purposes. It allows for things like having a hot spare, right? So that you can, in the event that you need to, if you have some dramatic hardware or network failure, be able to still service all the requests out of Couchbase, on a secondary cluster. And lastly, probably the main use case it was designed for is being able to serve data out of geographical regions, right? Keeping data close to your users, keeping those response times as quick as possible. So we'll go into all of this in a bit more detail in a bit, but the cross data center replication is, it's pretty granular in terms of how you control it. We configure it on a per bucket basis, and for us in Couchbase, a bucket is pretty much a logical data partition. And if you're looking at it in terms of a relational analogy, it's probably close to a database within a database server. And that's probably the only part that's applicable. So it's a push-based replication, and we allow for unidirectional or bidirectional replication streams. Essentially, it allows you to set up master-slave or master-master or master-master-master-master-master configurations for replication. So there's all kinds of different topology patterns that you can use. We'll look at those in a little bit. Cross data center replication also scales out linearly, so it can take advantage of extra nodes in the cluster, extra clusters that you're replicating to spread out your workload seamlessly. So, if we start talking about use cases, how you might go about using this, it's a new feature. You may not have thought about how you'd leverage it. Some of the things that you can do with just simple unidirectional replication, like we talked about before, hot spares, right? Having a spare cluster within the data center so that if you do have any kind of hardware issue, you're able to cut over your application servers to use that secondary cluster so that you can deal with the hardware issue if you have, right? Do maintenance if you need to, or any other kind of use case that you can think of for using a hot spare. Development and testing is also a really popular use case. In our line of work, we talk to operations teams, pretty much on a daily basis. And one of the things that we found that's pretty common around the more enterprise level ops teams is that one of the things that they want to make available for both the developers and their QA testers is the ability to have production data so that they can have realistic data to test against and develop against, right? And that is usually a very tricky thing to do. You're either doing a manual operation to manually back up the data in production and set it back up on a QA or a test cluster, or you're doing something different, right? With cross data center replication, what we've got the ability to do is configure a replication stream from the production cluster to a test or QA server internally in-house and allow our testing team and our dev teams to go about, beating on that thing without having to worry about it affecting production data and without worrying about it affecting production traffic. The last thing, that is pretty interesting is offline analysis and processing, right? So Couchbase, as it stands, is a really good tool for servicing large amounts of simultaneous writes. We have some customers that are doing 400,000 writes per second on their Couchbase clusters. And with the new indexing and querying capabilities that are available in the 2.0 release, sometimes they want to do analysis and regressions on that data. We have some customers that are actually using Couchbase as the front end to collect large amounts of monitoring data or manufacturing data from their manufacturing plants and replicate all that data to another cluster that's closer to their internal offices so that their managers can use that data and analyze it and use it to make better decisions about their processing. So it mixes a couple of things, right? Offline analysis and processing and keeping data close to where it needs to be. Now, if we take a look at bidirectional replication, or master-master, if you will, where we've got multiple clusters that are syncing to each other, writes are replicated. Use this for a number of different things, right? The first is distributing workload, right? You can have multiple data centers in the U.S. or in Europe or however you want to deploy them, and app servers connecting to each one of them within those data centers. And that allows your customers, your users, to be able to go to get routed to a location that's closest to them, still be able to get the relevant data, and also get better response times from avoiding having to go through a WAN link for every single request. So it's fantastic for that, right? It's one way that we handle scaling out to handle larger and larger user bases, larger and larger data sets, any number of other things. Again, the use case exists for keeping data local, for client-side operations or company-side operations, where those clusters may be located somewhere different from your main production data center. So a lot of different things that can be done with bidirectional replication. Lastly, we have the multiple, right? I like to call this the mesh. This is where every single cluster is replicating actively to every single other cluster. And it's an interesting configuration because what it allows for is really no single point of failure, right? If your entire data center goes down, there are multiple other clusters that have that data replicated that can come online, or not come online, but have traffic rerouted to them so that you can continue, with your business operations, with your application level requests, all without suffering any downtime. So locating these things within multiple data centers, whether it's across, a continent, allows for some pretty interesting things that can be done. And right now, I'm going to break for some questions if there's anything. Right? We encourage any kind of feedback. But if you guys have any questions, feel free to type them into the chat, and we will address them before moving on. We'll give you guys about a minute or so if there's anything that you're curious about for anything we've discussed so far, or any questions that you'd like addressed later on in the presentation. Okay, maybe not right now. As we're going, feel free again to jump into the chat and let us know what you're thinking, what you think about the technology. If you're curious about anything, we're happy to respond. So, if we start looking into some of the deeper aspects of this, considerations for how you might go about using cross data center replication, it is a cluster-to-cluster replication, and so with that, typically what we recommend is clusters at least being on the same platform. Right? If you are running, x86 Linux, on production, we'd recommend that you replicate to the same kind of platform. Stay with Linux. Don't try to replicate to a Mac cluster or a Windows cluster. There's no limitation on cluster sizes or configurations. So if you've got, a 40-node production cluster that's running a lot of data, and you want to replicate all this to, a 5 or 10-node cluster that's living in the test or QA environment, you're more than able to do that. It's able to map to that seamlessly because it uses our vBucket concept to figure out exactly where everything is, and it can map the data up accordingly. Right? So you can use clusters of different sizes. Not everything needs to be the same size with the same RAM configuration. Obviously, some things will work slightly better on larger clusters, but you can replicate to smaller ones without any issue. Like we mentioned before, XDCR is push-based replication, so it's driven by the source cluster. And what we're able to do is configure master-master replication simply by going to each cluster and configuring a replication and pointing them at each other. So the source cluster, if you will, is responsible for determining which documents to replicate. And there's a question from one of our attendees: is the destination cluster read-only? It can be, and it can also be write-only, or sorry, write as well. So I mean, you can set up the destination or the replication as a master-slave, if you will, right, with one production cluster pushing data to another cluster. And you might only read data off that other cluster, but you can also set it up with master-master replication, pointing in both ways, so that both clusters are capable of doing read-writes, and those read-writes will propagate, or those writes, I should say, will propagate back and forth, so that the data within those two clusters is consistent. XDCR replicates after we've written documents to disk. So it works, if you're familiar with how Couchbase works, it works a little bit differently in a slightly different flow than our normal write patterns. And we'll go into that in an architecture diagram in a little bit, but something that you should know, right? If you're writing multiple updates to a single document, what you're actually able to do is leverage some of the features in Couchbase. You know, online gaming is a really popular use case for Couchbase. And in that, you can imagine that documents are constantly getting updated with, you know, points or virtual goods or whatever that a user is accumulating. And those writes, you know, in a normal system would get persisted to disk. You know, let's say you're doing 1,000 of those writes to a given user document. Let's say it's a really good user over the course of a minute. What actually happens in Couchbase is, since we work in memory for a number of things, we're able to actually deduplicate all of those writes and persist down to disk only that last write. So 1,000 writes to a single document over a minute would map to one write down to disk and one replication over the network wire to another data center. So there's some benefits there as well. And we've got another question. How do you guarantee that master-master replication to the same key does not become corrupted? Great question. We actually have a slide on that. It's around conflict resolution and write collisions, and we'll be talking about that pretty shortly. So we'll be addressing that a little later in the next few minutes. And one more question. For a 3 data center replication, would you still do a master-master-master? It's up to you. I mean, you could do a master-slave-slave, you could do a master-master-master, or you could do a full mesh with all, you know, with each cluster configured to replicate to 2 data centers. You know, it's really up to you and your use case and your level of hardware and the kind of requirements that you have. So it's really flexible in terms of that sense. You could do master-master-master, you could do any kind of different topology. We'll cover some of the topologies as we go later on the slide. Another question is, what's the benefit for having a master-to-master replication? We do have master-master setup. Does it make sense to stagger the replication interval? Master-master replication is where you've got a data set that's got to be shared across clusters, you know, maybe in completely different regions. And since that data is shared, and since both those clusters are being hit by the application servers, you know, occasionally you're going to have writes that need to be replicated back and forth. And so in that case, you know, the use case applies for anything where you need master-master replication. The benefit of it is, you know, it acts as one big seamless cluster that's spread out across 2 data centers. In terms of staggering the replication interval, it's not something that we really do, staggering, but the replication is pretty much a streaming, continuous stream. As you make writes to one data center, they'll replicate over to the other data center. Okay, so going back to this slide, one other thing to know is that the indexing and view functionality that we have in the 2.0 release, we have design documents and view definitions that work with those functionalities. And only right now, data is replicated. So design documents and view definitions are not. They'll need to be manually replicated. And the replication itself is cluster aware. So some of you that have used Couchbase for a while have used the rebalance feature. You've added and removed nodes. You've had, you know, nodes go down, and, you know, you've initiated a failover so that all the data is still available and able to be serviced, you know, regardless of that hardware loss. The replication, at the same time, is also aware of these features and able to work seamlessly, you know. So as an example, if I have two data centers, right, and I've got master-master replication configured between the two of them, and in one of those data centers I add another 5 nodes, and in the other data center, you know, I lose a node because of hardware and I have to fail it over. The replication is going to continue seamlessly because the Couchbase replication is configured in a lot the same way like a Couchbase SDK or the Couchbase clients themselves. They're able to understand the cluster topology and able to work with the changes to that topology as the cluster goes along in its lifetime. So a couple different replication types. You know, here we've got 2 clusters. In the first one, what we've got configured is a master-master replication, bucket A to bucket A. So anything that gets written to bucket A in either cluster is going to get replicated over. You'll notice here that the replication is defined granularly at the bucket level. So it's not a requirement for you to have to replicate data across the entire cluster, right? You can configure multiple buckets and designate one bucket to get replicated, and the other buckets are local buckets. In the second example, we've got bucket B replicating to both bucket B and bucket C on the destination or on the remote cluster. And you know, this is something that you could do. I can't think of an exact use case for why you would want to do that, but it is something that you can configure in Couchbase. Lastly, we have bucket C in cluster 2 configured with a unidirectional replication stream to bucket C in cluster 1. And so again, another option for you in terms of how to go about configuring the replications themselves. So this is kind of a topology map of how these things look. You might have 2 data centers. You might have app servers in each data center doing read and write requests to the Couchbase clusters that are local to them. Within these clusters, right, we have our own internal replication mechanism that makes sure that all the nodes in the cluster, you know, distribute the data safely, so that if we lose a node within a given Couchbase cluster, we're able to continue servicing traffic for that. Additionally, we've got these configured so that they're both replicating to each other. And so in this case, if I if I have app, you know, in data center 1 writing to the cluster, those writes will get replicated to the Couchbase cluster in data center 2, so that the app servers there can read or write to those updated documents. So in terms of, you know, how this thing works internally, right? What actually happens when you make a write to Couchbase? This is a typical architecture diagram for us that kind of displays what happens on a single node of Couchbase. So we've got an application server, and what it does is it makes a write. It writes to essentially the managed cache, memcached, if you will, and it's able to do that write with a response time usually in the single-digit milliseconds. And that app server is going to, after it's been written to the managed cache, it is going to receive an acknowledgement and continue along with whatever else it needs to do. At the same time, to guarantee durability, what we're going to do is put that write onto 2 internal queues, our replication queue, internal replication queue, as well as the disk write queue. The internal replication queue is going to go memory to memory to another node in the Couchbase cluster, so that that document write is safe in case we lose this node. At the same time, it's also going to drain that write to disk and store it there, so that if we lose power to the Couchbase node itself, we can always restart it and that data will be there for us. Lastly, from there, after it's been written to disk, that document write goes on to the XDCR queue, and from there replicates over to another cluster. Internally, documents are replicated after a disk write has been done. So that's one important thing to understand. A lot of people are used to Couchbase where the write is immediately available within the cluster after it's been written to memory and replicated over to another node. In this case, it's available after it's done a disk write and after it's replicated. We use the concept of checkpoints to essentially track replication progress. And that's what really allows us to handle, you know, network blitz or network hiccups or system outages. Right? A node in the other cluster can go down, the entire cluster can go down, the WAN link or VPN can get disconnected, and Couchbase is able to understand what documents have been replicated and what documents still need to be replicated over to the remote cluster. In terms of master-master configurations where we might have write collisions, what we do is we use parts of the document data and the metadata that's stored with each document to create a unique sequence number so that we can determine and make an informed decision about which write should win in the event of a collision. And we'll talk about that in just a second. The collision detection is automatic as well as the resolution. If you were to make writes against the same document in 2 clusters that have a master-master replication configured, it would resolve itself automatically, and you get a uniform response from either cluster when you go to get that document back again. Replication itself is persistent, so if you restart or reboot the cluster, it will continue to replicate after it's back up and available. So in terms of configuration, it's a lot like normal Couchbase configuration. It's simple. Let's actually go to a demo system, and we will take a look at this right now. So, okay. So if everyone's able to see my screen, what I've got configured here are 2 clusters in Amazon EC2. I've got this one cluster, it's, the first node I'm on is XDCR1. In the second cluster, I've got something called XDCR5. And they're just 2 remote clusters that we are going to configure with replication. So we've got one bucket in here. This is the destination cluster. We're going to set up a unidirectional replication first, and then we'll do a bidirectional. But we've got an empty bucket in here. You can see here we've got a default bucket. We've got 0 items in it. And what we're going to do is we're going to set up our master cluster with a replication stream to this cluster, and we're going to write some documents to it. So in this case, on our master cluster, we've also got 0 items in it. And so we're going to go to the XDCR section, and we're going to create a replication stream. Now the first thing we do is we create a reference to that cluster that we can reuse again. And I'm just going to simply call this cluster 2. And I'm going to put in the IP of this 172.135 and credentials for that cluster, and that's all that's needed. So now I've got a reference to that cluster, but I don't have any replication streams defined. What I'm going to do is actually select a bucket from this cluster, and in this cluster I only have a default bucket. But if I had multiple buckets, I could configure specifically which one I want to replicate, or I could set up configuration so that I replicate all of them to the remote cluster. In this case, I'm going to pick a remote cluster, and again, I've only got one remote one set up, but if I had multiples, right, I could also configure multiple replication streams for those clusters. And lastly, the bucket I want this to replicate to on the destination. All right. So replication set up, and it is going to continue streaming writes to the remote cluster when there's writes. As of right now, we don't actually have any documents in this cluster, so let's go and change that. What we're going to do is run a load test that's going to just write a couple documents to our cluster. So you can see here we're doing around 150,000, 45,000 writes per second. Oh no, I was right, 150,000 writes per second. We've created about 869,000 items. And what we're able to do here is see the number of docs that have to replicate. And what we can also do is go to the destination cluster and look at its item count. And you can actually see here that it is slowly climbing in items. The replications almost count as operations per second, so they'll be seen as sets essentially. And we can see here replication activity. It's replicating over at the pace of around 40,000 items per second. Okay. So here we've got one cluster that's replicating all its documents to the remote cluster. You can see here that we're almost done. 800,000 items replicated over in 30 seconds or so, or probably not 30 seconds. I don't think I've been talking for 30 seconds. But what we're also able to do is, if I wanted to set up a master-master replication, I could create another cluster reference, cluster 1, and put in its details, and configure a replication from here to there. And that way, any write coming into either cluster will get propagated across the 2 clusters and be able to be accessed by any kind of application server. So that's how to configure cross data center replication. You can see it's fairly simple and it works extremely well. If we go back to the slides, here are the steps. You'll have a copy of these slides likely tomorrow, and you'll be able to download Couchbase 2.0 and give this a try if you like. So in terms of communication, right? Replication happens across two different ports. We use 8091, the REST port of Couchbase, so that the source cluster can get the topology information for the remote cluster. And the topology information essentially contains the nodes that are in that cluster and what vbuckets live on what nodes, right? From there, we use port 8092 to do the actual replication, and replication occurs between every node in each cluster. So as of right now, there's no gateway node that's responsible for replicating all those changes. Every node in the given cluster will replicate its own data over to the remote side. So, with that said, it's kind of implied that 8091 and 8092 need to be accessible between the two clusters over that network wire, whether it's a WAN link, dedicated WAN link, or dedicated VPN connection. We use checkpoints again to update the progress between clusters. That's what allows us to, maybe shut down the remote cluster, and when it's unavailable, replication will kind of pause, and when we restart it, replication will be able to pick up again and transfer data without any kind of errors. XDCR configuration cloud deployments. Probably half of our customer base is located in EC2 through RightScale or the generic AMIs. But cloud is becoming a very popular use case for deployment topologies. And in that case, that demo that we just showed you is actually running in EC2. They're within the same region, so it's kind of cheating. But if you were to do multiple regions or multiple zones or different configurations, it is supported and tested in Amazon EC2. You will have to use a name that's routable, right, when you're configuring the servers. So we have a best practice document for how to go about configuring cross data center replication in EC2. Usually either something like a DNS CNAME or the Amazon public elastic IP will suffice. One thing to note about XDCR is that the traffic that it sends between the two is not encrypted. So it is insecure, if you will. Generally, we'll recommend using anything that you would normally use to secure traffic between two remote locations. So you can use a VPN, a dedicated WAN link. There's a number of different solutions that you can use. I think there is something in Amazon called VPCs that can also be set up for security and securing that traffic. So performance of XDCR. I would not necessarily recommend, sticking Couchbase 2.0 on your existing hardware and just configuring XDCR and hoping everything works correctly. Couchbase, the 1.8, 1.7x, they didn't end up using a whole lot of CPU, and they were still able to generate massive amounts of performance. The 2.0 release is a little different in that respect. Cross data center replication is going to use more CPU. So if your existing clusters are set up, with maybe one core in them, you may need more CPU power to be able to leverage this feature. What we do internally is we have multiple parallel streams that are round robin through when we do the replication patterns from each node. And by default, there's 32 streams. The more cores that you have from a CPU perspective, the more we'll be able to leverage multiple streams to parallelize that replication, make things more efficient, make things more responsive. A couple other things. Network bandwidth is going to increase on each node. Not only are you handling application level traffic, internal replication, but as well, you're also going to be doing remote data center replication. So keep that in mind. It's a very simple thing to do the math on if you have a sense for the average value size of your documents and what your kind of load patterns are. I/O usage will also increase. Read I/O on the source cluster, write I/O in the destination cluster, and that's to be expected if you're doing any kind of replication. And RAM usage will also increase. So we recommend at least a minimum of allocating an additional 2 gigs of RAM to the machine so that it's able to leverage XDCR. And typically, that simply means just leaving 2 more gigs free at the OS level, not necessarily giving the Couchbase Server quota additional RAM. Of course, doing more complicated replication topologies is going to increase, the performance requirements of this, right? So if you're going to do a meshed replication of 8 nodes, you will end up using more CPU, disk and network I/O, and slightly more RAM to do that configuration. But at the same time, you now have the option of doing that in Couchbase. Conflict resolution. This is one of the questions that we had earlier. What happens if we, make a write to the same document in 2 different clusters that are configured with master-master replication? So our conflict resolution detection, resolution and detection is automatic. And what we do is we monitor multiple pieces of metadata within a document to create kind of a fingerprint for that document. So we use the document name, we use a sequence number that is incremented on each mutation, and a mutation is any kind of write operation, right? So a set, an add, an update, a delete, an expiration, those will all increment this numeric value. We use the CAS value. We use any flags and any TTLs used to kind of create a unique identifier for that document. And the cluster is automatically going to check the metadata for all these different things across the remote clusters when it goes to replicate to make a determination for, if there's something funky going on, right? If this document does need to be replicated over, or if it's already been written to since then, and if we need to resolve that conflict. So what ends up happening is that we use all this information and the algorithms on the Couchbase server to automatically and consistently give you the latest computed document version. And so, essentially the document with the most writes is going to win in terms of a master-master write collision conflict. From a monitoring sense, those of you that have used Couchbase before know that it's pretty good in terms of a database, in terms of monitoring statistics. 2.0 has over 277 metrics per machine at the bucket level that you can use to get a sense for exactly what's going on in terms of trends, for activity within the cluster, and now for XDCR as well. So we have stats that are specific to XDCR to help you get a sense of exactly what's going on, how much traffic is going through the box, and get a better sense of things. So that pretty much completes the presentation for cross-data center replication. And what we'll do right now is open things up for questions, if you guys have any, and answer those. So first question, is the feature to replicate design documents and views something that is already scheduled for a future Couchbase release? To answer you completely honestly, I don't know. I can check with our marketing team, and if you can make a note about the user that asked, we'll get back to you with a response for whether or not this is something that's going to be on the roadmap and in a future version of Couchbase. Another question, is the feature to encrypt replication traffic something that is coming in a future release? The answer to that is most likely a no. There are a lot of different technologies that you can use and leverage to encrypt traffic between sites. And honestly, the engineering work and time here is probably better spent on adding more features and more robustness to the Couchbase technology, as opposed to kind of reinventing the wheel for things that there are already solutions for. So unfortunately, I don't believe we do have plans to encrypt traffic between sites. Another question, why did you go with 2 queues for replication in XDCR? Is XDCR a form of replication, just a different physical segment? That's a great question, and one I actually asked myself when I found out that it was 2 queues. So, that's a great question because, our own internal replication that we now use within a cluster goes memory to memory, and it's very fast. Typically, it's, single-digit millisecond for us to replicate, to another node within a cluster. XDCR, as you guys saw from that architecture diagram, uses a completely different queue, and essentially it passes through the disk first. And essentially this is how it works in the initial implementation of it. We are looking at not merging the queues, but making them more similar, right? So as of right now, the document has to pass down to disk before it's replicated over, and that's obviously slower than if it went straight from memory. So one of the things that I know that we are looking at later this year is adding that kind of functionality to the replication feature. Next question. Can you elaborate on what happens if design docs and views are not replicated? How do we get those propagated to other clusters? Good question. So design docs and views are used for the indexing and querying features in Couchbase 2.0. And essentially, for a JSON document, you'll have attributes and values within that document. And the indexing and querying functionalities of the design docs give you the ability to define indexes against specific attributes in those documents, right? So if I'm looking at something that has city, state, zip code, I can define an index on zip code and then query everything that matches my local zip code, okay? The views are essentially JavaScript functions, and those can be replicated over through the REST API. And so, if you don't have the design doc and the view replicated, other side. But it's actually a very simple matter. Going to production, a lot of users will actually go and programmatically upload the views and design docs. So it's not a hard thing to replicate that to other clusters. So to answer your question, if the views and design docs are not there, you just can't run queries on that other cluster until they are there. It's a very simple thing to get them replicated over through normal production deployments. Other questions?
All right, thank you, Alex, for this excellent session. If any of you has any other question, this is the right moment to ask. And if not, you can contact us offline, and we will try to get back to you shortly. So again, thank you for being with us today, and we hope to see you again to future webinars. Thank you.